Hi guys, today I am discussing a topic force. This one is the first chapter for ICSE 10th. Now some of the points out of the syllabus here as force, type of forces. Type of forces has been removed from here, but I will simply explain for you here. Force is that push or pull. Force is that push or pull which either change or tends to change shape or size, position, direction of motion of the body. This one is the universal definition of force. Force is that push or pull which either change or tends to change shape or size of a body, direction of motion of a body. Clear? So this one is the force. Now types of forces. Here types of forces are not involved in your syllabus, but we can explain this one in short way. Types of forces: contact force, electromagnetic force, tension force, gravitational force, nuclear force. Like these forces are involved in types of forces. But in universe there are 4 forces only. Remaining forces comes out through these forces. Now the 4 forces, always remember these points, students. There are 4 forces in universe. First one, gravitational force. Second, weak force. Third, electromagnetic force. And fourth, nuclear force. The strongest force in these nuclear force, and the weakest force is gravitational force. Now this one is all about the force and types of forces. Clear? Now we have next heading is motion. There are 2 types of motion mentioned in your book. First one, what is motion? A body is said to be in motion. A body is said to be in motion if its position changes with respect to its surrounding. A body is said to be in motion if its position changes with respect to its surrounding. Suppose bus is moving from station and towards your hometown. In that case, the shops and buildings near the bus stand with respect to the bus act as surrounding. When this one bus move from this, in that case these surroundings with respect to the bus will change. It means bus will be in motion. Clear? Now here we have types of motion which are mentioned in your book. I will discuss only those points which are mentioned in your syllabus only. Clear? Otherwise this one discussion will be a huge discussion and you will be bored. You will feel bored. That's why I will discuss only those points which are in your syllabus only. Now translational motion or linear motion. Translational motion or linear motion, when a body moves on a straight path. When a body moves on a straight path, then the motion is called simply translational or linear motion. When a body moves on linear path, we can also write in this way. The body moves on a straight path or a straight line, then its motion is translational. Means the required condition is translational. It means position of a body is changed with respect to initial point, but this one must be on line. Second one, the rotatory motion or rotational motion. Rotational motion means when a body rotates or move around the axis which passes through the body itself. For example, motion of the top. Motion of the top, because top revolve around its axis which passes through its own axis. In same way, suppose this one circular wheel is pivoted here. In that case, if the force applied on this, in that case this one begins to revolve or rotate around this. Clear? So here this one is the rotational motion. Clear? Example of rotational motion, here this one is, suppose a wheel is pivoted here. In that case, when the force applied on this one end of this, then this one begins to rotate. Clear? And the example of linear motion is when the car moves on the straight road. In that case, this one is the linear motion or translational motion. Clear? Now, the important topic here, this one, moment of force or just torque. Moment of force means turning effect acting on a body is called moment of force or torque. The turning effect acting on a body about any axis. Any axis means the axis which passes through body, or it may be out of the body, but this one be axis. So then the moment of force, again turning effect of a body about an axis is called moment of force. Example of this one, when the door is open, this one is the hinge. Clear? This one is the hinge where the door is fitted. Clear? Here this one is the handle and this one is the hinge. Hinge, you know, which lock this one pillar and door is called hinge. When force is applied on this, clear? When force is applied on this handle outward, in that case it will open about this. This is the distance of the fixed axis about which this one door will rotate. Clear? Here the moment of force, how do measure this one? This one we measure as tau is equal to force into its perpendicular distance from axis of rotation. Axis of rotation. It means force into this perpendicular distance, this d. Here this one is the direction of force. Here the black marker acts as the force, and this one blue marker is the perpendicular distance which is lies on the plane of the board, plane of the board of the door. Clear? In that case, If you pull this one outward, in that case, this one door will be open around this one hinge. Here, in that case, the moment of force is measured as the product of force and its perpendicular distance from axis of rotation. Clear? Here this one hinge act as axis of rotation. Its SI unit. SI unit is Newton meter and quantity vector. This one is also a vector quantity. Clear? So this one example is sufficient. Clear? With the help of which we can say you can easily satisfy it. More example, you can study the book. Here the factors affecting the torque. This one is the very important, and in ICSE board we have a question of marks 2-3 maximum. You have to write answer in short words. For example, what do you understand by moment of force or torque? On which factors is depend? So here the factor we can find here. This one first, force, magnitude of force we can say. Magnitude of force. Second, perpendicular distance. Perpendicular distance from the line of action. Perpendicular distance of the force from the axis of rotation to the line of action of the force. Perpendicular distance of the force from the axis of rotation. Axis of rotation. Now the next important point, sign of the torque. Sign of the torque. Here, sign of the torque. Sign. If the force acting on this anti-clockwise, clear? This one is taken as positive sign. Means this one, if the force is acting on this anti-clockwise, then this one is represented as positive sign. Clear? In anti-clockwise, this one is represented as positive, and in clockwise this one be represented with negative sign. Clear? So these are the three important things about the moment of force. Once again, moment of force, the turning effect acting on a body about axis of rotation is called moment of force or just torque. Clear? In mathematical way, how to measure this? It is equal to the product of magnitude of force and the distance of the force from axis of rotation. Clear? By formula we can write this one, tau is equal to F into D. Here the SI unit of this Newton meter, and quantity, this one is vector quantity. It has direction as well as Now the factors affecting, important point, factors affecting the torque. On which factors? This one torque will depend. Here magnitude of force. Here magnitude of force, and second perpendicular distance of the force from the axis of rotation. Here, dear student, if you have know the formula of any physical quantity, then the quantities which are involved in this also act as factors affecting that quantity. Clear? Now the important thing another is this sign. If moment of force is taken, if the moment of force taken along anti-clockwise, this one is represented by positive sign, and if the clockwise, in that case it is represented as negative sign. Clear? Here suppose we have this one wheel. If we rotate this one with the help of this as well as this, in that case suppose one force is applied along this direction and another one is this, in that case this one will rotate anti-clockwise. It means in that case the torque is taken as positive sign, and if this one force acting on clockwise direction, this one is also clockwise, in that case the moment of force is taken as negative sign. It means in clockwise it is represented by negative, and anti-clockwise it is represented as positive sign. Clear? Now second important point is couple. Couple. Couple means when two equal and opposite parallel forces. When two equal and opposite parallel forces acting on a body not in same action of line. Clear? The forces are called couple. When two equal and opposite parallel forces not acting on the same line of force, on same line of action, we can say same line of action. Here suppose this one, suppose this one, I have a diary. If I am applying here the two forces, one with this hand and another one with this hand, this one is outward and this one inward, in that case this one begins to rotate. Clear? It means this one is a couple. Pair of forces which are equal, opposite and parallel, which are equal, opposite and parallel, not acting on same line of action. Line of action same, it means here this one force acting on this diary on this line, here this one force acting on this diary on this line. Here the two lines are parallel but not same. But in case of this, when we apply these two forces on this diary like this, in that case this one with this hand, suppose I pull this one diary downward and this one with upward, in that case these two are equal, opposite direction, but their line of action is same. But their line of action is same. That's why it will not move anywhere. This diary will remain same. It means here the two forces acting on the diary equal, opposite, but their line of action is same. That's why this one diary will not move anywhere. But in case of this, when force acting on this side and this side, this one is outward and this one inward, in that case this one diary begins to move. It means this one is the couple. Here these two are equal in magnitude, opposite in direction and parallel, but their line of action is not same. I think you should be clear with this example. Clear? So this one is the definition of couple. A couple means two forces, a pair of forces which are equal, opposite and parallel, but not acting on same line of force. It's called couple. Clear? Now how to calculate this? कैसे जी मीन्स इसको कैलकुलेट करेंगे? Now suppose AB is a log over which there are two forces acting on this. This one is D1 and this one is D2, and we are calculating moment of force about this. In that case, here this one is rotated anticlockwise, this one is also rotated anticlockwise. Clear? So moment of this one, this force, Fe is equal to F into D1. It means force and its perpendicular distance from line of action. Clear? And moment of FB. Here this one F into T2. Clear? You both acting on this anticlockwise, that's why their sign will be positive. Hence, net moment of force is equal to F1 F into D1 plus F into D2. Here we can take F as common, we get D1 plus D2, and sum of these two is D. It means here the net moment of force or due to the couple is any one of the force and the perpendicular distance between the forces. And here moment of force is force and the perpendicular distance between perpendicular distance of the force from the axis of rotation. Clear? Here the difference between these two, couple and moment of force. Here in case of this, because rotational motion is impossible due to a single force. Here we can say these two are the same thing, but here the two forces we can see here, but in this case we can see one force only, but here one force is the hidden force, where this one is acting due to the hinge or the axis of rotation. In same way here, when this one wheel is rotated with single force, in that case the force acting on this pivoted point will act as another force. Is it clear? No. So here the difference between these two is this. will take another topic, principle of moments. So principle of moments, in that case the number of forces, principle of moments, here the principle of moments, we can easily understand principle of moments. Why I am not erasing these? Because with the help of this we can understand principle of moments. According to principle of moments, sum of anticlockwise moments is equal to sum of clockwise moments. It means sum of clockwise moments or anti-clockwise moments. Anti-clockwise moments is equal to sum of clockwise moments. With the help of these, there is one numerical must be in board exam. Clear? So here this one, suppose we are acting the moment of force about this O, distance of this one is d1, distance of force F1 from this one is d1, in the same way distance of this one from this is d2, distance of F3 d3, and distance of F4 d4. In that case, here we have a formula F1 into d1 plus F2 into d2 is equal to F3 into d3 plus F4 into d4. Here sign, if we take sum of these, in that case these will be represented by negative sign. In that case the concept of this one will be true. Clear? Suppose we will write this one in this way, F1 into d1 plus F2 into d2. So then this quantity will be represented as negative sign, because here the moment of force in clockwise taken as negative sign. This one is the important point here. F3 into d3 minus F4 into d4 is equal to 0. Clear? So this one is the conceptual portion of this chapter. Now the remaining is theoretical portion. Now we have equilibrium. This one is the remaining portion of the chapter, force. Equilibrium. A body or a system is said to be in equilibrium if all the forces acting on the body or a system, their net sum is 0. Clear? Whether the body be in motion or stationary. if net sum of the forces, a sum of the magnitude of the forces acting on the body, whether it is in motion or at rest, is zero. In that case, a body is said to be in equilibrium. Clear? A body is said to be in equilibrium if the sum of the forces acting on the body, whether it is in rest or in motion, is zero. In this way, we can say equilibrium is of two types. Static equilibrium. Static equilibrium means a body is said to be in static equilibrium. A body is said to be in static equilibrium if sum of the forces acting on the body remains zero. Means a body is said to be in static equilibrium if net force acting on the body unaffected the body from its position. It means sum of all the forces acting on the body is zero. Clear? A body is said to be in static equilibrium if all the forces acting on the body doesn't affect its position. Here the dynamic equilibrium. Dynamic equilibrium means a body is said to be in dynamic equilibrium or in motion. Clear? A body is said to be in dynamic equilibrium if its motion, its state of motion be unaffected when the number of forces acting on this. It means sum of all the forces acting on the body is zero. We can say a body is said to be in dynamic equilibrium if number of forces acting on a body do not affect its motion, then the body is said to be in dynamic equilibrium. It means the net forces acting on the body while it is in motion is zero. In that case, it is said to be in dynamic equilibrium. Clear? So, in this way, we can clarify the definitions. Definition you can't learn. If you learn 2 or 3 days, after 2 or 3 days or 4 days, you will forget. Clear? Then you can feel this one, you can understand this one, then you can write. If you will understand here, in that case, you can write these definitions easily. Now, what are the conditions for equilibrium? What are the conditions for equilibrium? First condition, net forces acting on the body or a system remains zero. And second, first one, sum of all the forces acting on the body or a system remains zero. And second one, algebraic sum of the moments, acting on the body or a system remains zero. Clear? Now we have center of gravity. Center of gravity is the point. Center of gravity is the point on a body. Center of gravity is the point on a body at which moment of an algebraic sum of the moments of the weights of the particles be zero. Here, in other words, we can say center of gravity is the point on the body at which whole weight of the body acts. Clear? The center of gravity is the point on a body at which whole weight of the body acts. Clear? As in case of circular ring, center of gravity is center of the circle. Scale, suppose we have a scale, then its center of gravity, its midpoint. Clear? In same way, we can observe center of gravity of any irregular shaped body. Clear? Now we have a circular motion. Circular motion means when a body moves on a circular path, then its motion is circular motion. And uniform circular motion. Uniform circular motion means when a body moves on a circular path with constant speed. When a body moves on a circular path with constant speed, then its motion is called uniform circular motion. Clear? Centripetal. Now, when a body moves in a circular path, then a force required to rotate in a circular path. When a body moves on circular path, then a force required to move a body in circular path, which always acted towards the center of the circular path. Suppose with the help of stick we rotate a ball with the hand in horizontal circle. In that case, a force acting on this one ball towards the center of the circle of radius r is called centripetal force. And here we can give the formula of this, because this one is in 11th standard you will study F is equal to mv square over r, where m is mass of the ball, v is velocity or speed, and r is radius of the circular path in which the body is moving. So here the factors affecting, because this one formula is not in syllabus of 10th ICSE, this one is on 11th. Clear? This one is in 11th class, that's why. But for the factors, I have written this: mass, velocity or speed, or radius of circular path. It means there are three factors on which centripetal force acting on a body be depends. Now here we have centrifugal force. Centrifugal force, you can observe this one force here when we are rotating a cream, milk, and in that case the cream is moved out from this. So it is due to centrifugal force. Clear? Centrifugal force, when a body moving in a circular path, then the force experience in opposite direction or radially outward to the centripetal force. When a body moves in a circular path, then a force experience radially outward to that circular path is called centrifugal force. It means centrifugal force in opposite direction of centripetal force. Here this one is called positive force or not real. This one force is positive force or kya? Or in other words, this one is not a real force. Clear? So this one is all about theoretical portion of this course. And now I will calculate a numerical, a particular topic, moment of force here. How you can calculate these types of numericals, you can try these. And before pause the video, you can write this. Here we have a question, a uniform half meter rule. You have a meter scale. This one, but this one is half. Meter scale is of 100 centimeter, but here we have a meter scale half, 0 to 50 centimeter. can be balanced at 29 centimeter mark. Here this one will be 25, sorry, and here this one is the balance at 29 centimeter. Clear? Definitely the weight of this one whole scale will act here, and this one is balance here. Clear? This one is the midpoint, and here this one is the balance. Clear? 20 gram is hanged from its one end. Definitely here this one is the remaining part, this one means half, and some more is here, that's why it will tilt. In that case the weight will hang here 20 gram. Clear? Because this one is pivoted here or knife edge is here, that's why definitely this one portion is larger than this, that's why this one portion will tilt. Clear? So we have to hang weight of 20 gram to balance it. Now in that case it will be balanced. Here this one is the diagram. Clear? Means answer of first part. Draw the diagram. Here we have half of the meter scale. Meter scale is of 100 centimeter, but we have half of meter scale. It means this one is 50 centimeter. Clear? Remember this one always whole weight of the body always at mid of this. In case of rod, I have mentioned this one in center of gravity of the rod. This one always act at midpoint. Clear? Here we have a scale, half of the scale. That's why half of the scale, the whole weight will act at the mid of this. It means at 25 centimeter. Clear? According to question, this one is a knife edge is at this. It means this one is balanced at this, for which we have to hang 20 gram from its one end. So definitely we will hang 20 gram here, because more than half portion of the scale is towards left of this. That's why this one will be tilt. So to balance this one, a 20 gram weight must be hanged to the right of this. In that case it is in equilibrium. Clear? Now solution of second part. Find the mass of the half meter rule. You have to find mass of this or weight of this. So in that case, according to principle of moments, force into its distance. Here the distance between these two is 4 centimeter, is equal to, here this one is 29 to 50. It means 21 centimeter into 20 gram. Clear? W is equal to 21 into 20 upon 4. Here 4 5 ja 20 and 21 5 ja 5 1 ja 5 5 2 ja 10. It means 105 is the weight of this half meter. So these type of examples you have to practice. Like and comment if you understood from this lesson what I have taught you. Dear student, if I have to need more and more on physics, then you must comment, sir, yes, we understand this, or no. You can ask whatever your difficulties. Thanks for watching me.
Thanks for watching.